and catching the exception in the catch block. Notice again that the exception object you're creating up here in the try block is of class arithmetic exception. The object that you're catching down here is called EX, and it is expected to be of type of a class called exception. These two are different, and the reason that they're different is that arithmetic exception is a subclass of exception, as we will see a little later. Now, if we do indeed reach the catch block, it means an exception was produced over here because we went into the if block, we did produce, we did throw, that arithmetic exception was caught, and we print out, or we do whatever needs to be done accordingly. In this case, we're just printing out a message. And after we're out of the catch block, we continue, code continues, resumes execution outside of the catch block. And this is the difference between what happens when you catch an exception and when you catch an exception, or when you don't catch an exception. When you don't catch an exception, the Java compiler throws up an exception like we saw in the very first example. In this case, exception is caught, you can handle the situation however you need to, and code continues to execute. So let me do a quick demo of that. So first, let me run this without an exception. Two numbers are 4 and 2. 4 divided by 2 is 2, and execution continues. So we did not go into the if condition. There was no exception thrown. The division just happened, and after the division happened, we jumped to this last line of code. Now let me run this again. This time, let me give 3 and 0 as input. And obviously, this will produce an arithmetic exception. You can see exception, an integer cannot be divided by 0, which means we threw this exception, we went into the catch block, but after the catch block, the code still continues to execute because we see this last line, execution continues. Still produced over here. And that's the difference between using exception handling in code and not using exception handling and not catching exceptions. So basically, if you do handle exceptions, you have the possibility of not letting your program crash and terminate terminate abnormally. Now, this was kind of a very simple example in the sense that all the code was inside the main method. Now, any project of even moderate complexity will usually have multiple methods, multiple classes, so when an exception is produced inside a method, the catching part of that exception has to be handled slightly differently, or have to do some additional work for that. So we'll start with something simple, and we'll move on to examples of increasing complexity. So here's another code example. This one is called quotient with method. I'll start on the right side. The main method is over here on the right side. And again, we take in two numbers, just like before, two integers, number 1 and number 2. We have a try block. But inside the try block, we're not performing the division inside the main method. We're not doing that. Instead, to do the calculation, we're calling a method called quotient. And we're passing in two arguments, the number 1 and the other integer, number 2. And the method quotient is going to do the actual division for us and is going to return the result. which is expected to be, which has to be another integer, which will be stored in this integer result, and it'll be printed out in the following line. All of this is happening inside the try block, and if it's happening in a try block, it means somewhere over here we might see an exception. That exception is called like before by this catch block, which is again printing out inside the catch block. We're just printing out this message saying that an exception happened due to division by 0. And just to demonstrate that the code continues to execute after that, we stick with that line that we had, execution continues, just a message printed to screen. So let's go into the quotient, into the quotient method. That's this one over here. The quotient method returns an integer and takes two arguments of type integer, number 1 and number 2. And in here, we have an if condition. If number 2 happens to be equal to 0, we are throwing an exception, like before. Otherwise, so this is outside the if block. Otherwise, we are returning the result of number 1 divided by number 2. Now here's the same code pasted into a NetBeans project. Project is quotient of method, and we have a main method over here and this method quotient. And let's see how this works. So just to understand this again, this line over here, calling the method quotient, will either return an integer, or it will send back an exception, which is not an integer. And if it throws an exception, we expect to catch that exception in the catch block in the main method. So you can see the exception is produced inside, is thrown inside the quotient method, but caught in the main method. Let's see if this works. Okay, so first of all, just to check for correctness, let's just run this code without problems. 4 divided by 1 is 4. No problem. Now let's try this again with 5 divided by 0. Well, this will produce an exception, and there you go. Exception: an integer cannot be divided by 0. This is the message produced or printed inside the catch block. Now let's take this one step further. Let's look at another example which does not terminate after just one attempt at division. And we look at this example called input mismatch exception demo. And here's the code for this. So we go back to only a main method in this project. Again, the way we do this is we create a scanner object called input, and we have a do while loop. And in the body of the do while loop, we have a try block and a catch block. And let's see what happens. So in the try block, get an integer, store it in number. Print out that the number entered is this. Now, notice over here, so this, I should mention, this is not, we're not doing division in here. Basically, we're expecting over here, we're using the next int method for the scanner class, which means we're expecting to receive an integer from the command line. Now, you can really, the user can type in anything, text, a non-integer number. All of those maybe all of those, for this example, all of those qualify as invalid inputs. And that's basically, or actually, we have a mismatch between the type of input that we're expecting over here and the type that the user might give. So in that case, this is actually another type of exception in Java. It's called an input mismatch exception. And if that exception is thrown over here in this line, we jump to the catch block, and this message is printed out. Try again. Incorrect input, an integer is required. And we call the next line method on input in order to discard whatever input was received, and get to the end of the do while loop, and this continue input flag was initially set to true, will be at true if there's indeed an input mismatch exception, because continue input is set to false only if we pass by this line and the next line and reach this line where continue input is set to false. So if there's an exception at this point and we jump to the catch block, continue input is still false. I'm sorry, continue input is still true, which means we re-enter the do while loop over here, and we basically ask the user to try entering another integer. So let's try this out. Let's see if this indeed works the way it should. So here we have the same code pasted again into the NetBeans IDE. Okay, run this. So it's asking for an integer. Let me first enter something invalid, 0.5. And there you go. I got an input mismatch exception. The catch block prints out the message, try again, incorrect input, an integer is required. And we go back to the start of the do while loop, and I'm being asked for an integer again, and let me enter something invalid again, a bunch of characters to enter again, incorrect input. I can keep doing this until I enter an integer like this, 12,876. There you go. And we exit the program. So you can see you can do neat things if you know what kinds of exceptions Java produces. And so let me give you a slightly bigger picture over here. So I already mentioned that exception is this superclass of subclasses of exceptions in Java. The exception class in the Java API is a subclass of another class called throwable, which is a subclass of object, which is, of course, a superclass of all classes. I also mentioned early on that I'm deliberately not using the term error over here, and the reason is that exceptions and errors are slightly different things in Java. So errors are generated by the JVM, the Java Virtual Machine, the software on which our application is executing. Now these errors in the JVM are rare. If one does occur, there's usually very little to nothing there's nothing you can do. What we're really more interested in are the exceptions. And exceptions are produced by the applications that we're running, that we're writing. And among exceptions, uh, among exceptions, uh, as a subclass of runtime exceptions, as you can see, these are the ones that we've been looking at right now. So, the arithmetic exception, the input mismatch exception, others like the null pointer exception, which you'll deal with when we start using files, index out of bounds exception, when you're using an index to an array that is larger than the size of the array, uh, illegal argument exception, when you're providing an argument to a method that is of the wrong type. These are all different types of exceptions that you can expect to see some point. Now, runtime exceptions and errors and their subclasses are collectively also called unchecked exceptions. All other exceptions are known as checked exceptions. And the Java compiler will force programmers to check and deal with unchecked exceptions. Again, when we come to file handling, you'll see that that's true because you can't just open a file. Lots of things can go wrong that when you're trying to create a new file, and so you have to handle that exception there. So opening a file in Java inevitably involves using a try and catch block. We saw the null pointer exception. Yeah, that is usually generated if you try to access an object through a reference, through a handle, before an actual object has been created and assigned to it. So basically, the declaration of the object is not connected, is not pointing to any existing object in memory. And here's another view of what we call unchecked exceptions.